Now in binomial distribution, we have learned that let's say we toss a coin 10 times and we have to find the probability that we get 4 heads. So let's say X is the number of heads and we have to find the probability. We write it as 10C4. The probability of heads is 1 upon 2, so that will be to the power of 4, and the probability of not heads, or in this case it will be tails, will be 6. Now let's say if n was 100 and we had to find that the number of what is the probability for 70 heads. So in that case, the working will be, we'll write it as 100 C70, 1 upon 2 to the power 70, which is the number of heads we want, and this is representing the number of tails, which will be 30. Now, instead, if the question was find the probability that we get more than or equals to 70 heads. Now, in that case, we'll have to find all the probabilities from 100C70, then 100C71, 100C72, 73, and so on. And it will be quite a lengthy task. Now, in certain cases, after investigation, it has been shown that if n is large enough, the binomial distribution represents a normal graph. So it can be approximated through normal distribution, which is easier to perform rather than doing all these lengthy calculations. Now, now to decide whether when we use normal approximation to binomial distribution, we find the value of np or nq. So let's say in our case, in this question, we had n is 100 and the probability of heads was half. So we'll multiply and this is coming out as 50. So the general idea is that if NP is greater than 5, in that case, a binomial distribution can be approximated to be as a normal distribution. Now, in a binomial distribution, we have N and P, and when we have normal, the parameters are mu and variance. So from the binomial distribution, we can find the mean and variance. The mean for a normal distribution is given by N times P, and the variance is given as NPQ. Once we find this, there's one more thing that we'll have to remember whenever we are approximating, as we know that binomial is a discrete, we talk about discrete variables, and in normal, we are talking about continuous variables. Now, in continuous variables, we learned that it takes up a range of values. So let's take an example that if the question was find the probability of x is equals to 13. Now, in a binomial distribution, given that n is equals to 20 and p was 0.4, we can simply write it as 20C13, 0.4 to the power 13, and q will be 0.6. So that will be 0.6 to the power of 7. However, as in continuous, we have to take a range of values. So in that case, we perform a simple task that is called a continuity correction. As in normal, we cannot take a single specific value. So let's say if you're talking about 13, and if the question is if we have to find the probability for x is greater than 13. Now for a continuous value, we know that it can take values as 13.001, 13.1, 13.0001. So to simplify this, we treat a number like, let's say 13 as in between 12.5 and 13.5. Now let's say if it is greater than 13, it means that 13 is not included. So in place of x, the x value will be taken as 13.5. So when we are doing the normal distribution where we use x minus mu upon standard deviation, we already know that we can find mu by NP and variance by NPQ. So we can just square root the variance and we'll get the standard deviation. For this x value, now let's say the question was x is greater than 13. In place of x, we'll take 13.5 minus the mean divided by the standard deviation. If it was x is greater than equals to 13, in that case, as 13 is included, then we'll take the value 12.5. So in this case, that will be taken as 12.5 minus mu upon the standard deviation. And instead, if it was probability for x is less than 13, So it means we have to go below 13, and as we cannot take 13, so we'll take 12.5 instead of 13, and that will be 12.5 minus mu upon the standard deviation. And if it was x is less than equals to 13, so in that case, as 13 is included, so we'll write 13.5 minus mu upon the standard deviation. So what we'll have to remember is that whenever we are doing approximation from discrete to continuous distribution, we'll have to do the continuity correction, and when we have continuous values, so we take a range of values. So whatever question is given, we'll take that particular number as a range of values, 0.5 more and 0.5 less. And then depending on what the question is, we will choose a value accordingly.